Somewhere like.
Okay. So all we have left in chapter 4 is one word problem, but the majority of today we're going to work on the review. Remember, you need to do the review. Just me doing examples and you following along is not the same as you actually working them out, because you're going to find out that, maybe you kind of know it, but don't fully know it, or catch your little mistakes. Practice, practice, practice. And remember that the test covers chapter 3 and chapter 4. So there may be stuff in chapter 3 that you totally forgot, right? So that's what I want to spend the most time on. So this last word problem, I don't want to stress too much about it, but I do want to give you experience with harder ones. I do want to give you experience with harder ones. So this would be a harder example. And just to kind of get it started, our input, our x is going to be in months, time. Okay, time in months. And our output, y, is going to be video games sold. Basically, it's video games, right? So number of video games sold. So the reason why I want to talk about this one is this is a kind of a harder example, and I want to expose you to harder ones. So here's our example. And again, if you saw this on the test but didn't know anything, didn't know what type it is or anything like that, you have to look at this equation and decide, if I'm going to take the derivative of this, is this going to be product rule, quotient rule, chain rule, or one of our 4 special cases? And which one is it? Okay, a couple things are going on here. Number 1, you could do quotient rule because you have 2 things being divided. Totally can do quotient rule. But if you're like, quotient rule is really long and I don't want to do that, and I prefer one of the other ones, what can I do to rewrite it? Yeah, I can rewrite the entire denominator raised to the 1. And if I raise the entire denominator to the 1, when I move it up, it's going to be what? Raised to the negative 1. So that would be an example of rewriting it to make it a little bit easier. Now, is this chain rule or is this product rule now? Chain rule. The reason why it's chain rule is this is just the 10,000. It's not 10,000x. If it was 10,000x or x squared, then you'd have to do product rule and chain rule all together. But this is going to be chain rule. Okay? So I've given you the setup, but I'm going to give you a couple minutes to do it on your own. But before you do it, let's remember chain rule. How do you do chain rule again? How do you do chain rule? Exponent goes to the front. Then what? Inside stays the same. Subtract 1 from the exponent. Step. Derivative of the inside. So the exponent's going to go to the front. Inside's going to stay the same. Subtract 1 from the exponent. And then derivative of the inside. Whatever you have to do to take the derivative of the inside. So I'd like you to take the derivative of this one. Don't simplify it. Just take the derivative of it. Don't simplify it. Just take the derivative of it. Again, this is the harder one. Just the derivative, don't worry about simplifying. Just the derivative, don't worry about simplifying. About another minute.
Yeah. Oh, I got that.
Because I was like, oh man, this is over, right?
Yeah.
I didn't do that. You already did it? No. Okay, I was gonna say, how did you?
No, I don't.
Oh, that was, okay. I was like, you should do it. I don't know how to do it yet.
All right, so let's see how we're doing. We're going to go through this slowly. If we make a mistake, let's figure out where that mistake is and what's going on. Okay? So the -1 goes in front. We get -10,000. We okay? Inside stays the same. The -1 becomes -2. Stop there. Any questions up to, we're not done. Any questions up to this point? Okay?
I felt like the 10,000 was separate.
What do you mean?
Like, there would be like 10,000 was like separate, and there'd be like a 1 in front of it with 2.
If you had 10,000 times 1, it wouldn't change anything. You have a -1 in front of the parentheses?
Yeah.
Then -1 times 10,000 is -10,000. That works. Okay? It's still being multiplied, just in 1 step or 2 steps. Okay? Now, what's the next step? Derivative of the inside. Whatever I have to do to find the derivative of the inside. So I go to the inside. What's the derivative of 1? 0. Now the derivative of this, right? That is a special case E. So what happens to the number in front? Stays in front. How do you take a derivative of an E? Rewrite it, step 1. What's next? Derivative of the exponent, which is -0.4. Stop there, that's the derivative. Stop there, that's the derivative. If you didn't get that, try to figure out what happened, right? -1 goes in front, inside stays the same. Subtract 1, derivative of the inside. We'll simplify in a minute, but let's make sure we got the derivative correct first. Yep. How do you take a derivative of an e? Step 1, rewrite it. Step 2, derivative of the exponent. Okay. Questions? Now, the cleanup. When I go to clean this up, what are some things I can do to definitely make it simpler?
The first thing about the last.
Yeah, well, a bunch of stuff. So first of all, see that -2? How can I make that -2 positive? I can drop it down. So that kind of gets out of the way, makes it a little bit easier to deal with. And it becomes a +2. Now, what things can I multiply? -10,000 times 0.5 times -0.4. Those are all just numbers being multiplied. So instead of just leaving them where they're at, so if I take -10,000 times 0.5 times -0.4, that gives me 2,000. It's a lot easier to deal with than all of that. Still have the e to the -0.4. So to me, that is a bit simpler. To me, that is a bit simpler. Are we okay? Yep.
So you wouldn't do it like separate 10,000 times this, and that gives on 10,000 times 0.4.
Well, you can do this times this, and then times that. But would I be distributing it? No, there's no plus or anything like that. Is that what you mean? Those are just 3 numbers being multiplied. Is being multiplied by this, which is being multiplied by that.
So that's not
Okay.
0.5.
Plus. It's not a plus.
It's not a plus.
It's a times.
Okay. Oh,
What happened? So this times this is all 2,000. You okay?
So you would not do -10,000 times 0.5 plus -10,000 times -0.4.
Nope.
There's no plus.
Yeah, there's no plus anywhere.
Alright.
Yeah, literally, if I just took this, moved it next to it, took this, moved it next to it, it's just 3 things being multiplied.
True.
Okay? Now, here's the tricky part. We're going to plug in not 24 months. We're going to plug in 5 months. I want to know what happened at 5 months. Okay, so here's what you're going to do. What goes in Y1? The original. Now again, you can put this original, or you can put this original. I'm probably going to put in this one. So that's going to go in Y1. This is going to go in Y2. And what's going to go in Y3? The derivative in the calculator. Okay, so Y1, original, Y2, derivative that I did, Y3, derivative in the calculator. When you plug in 5 months, which one should match? Y2 and Y3. Okay, and explain what 5 months is in Y1 and what 5 months is in the derivative. So this is going to practice our calculator. So you can type in that. You can type it anywhere.
I should do a job.
Okay. You want to check your work. Again, I'm not going to write the sentence. I want you to write the sentence. If you plug 5 into the original, you would get 9,366.2. If you plug 5 into the derivative, you would get 237.45. If you're not getting those numbers, something's wrong. And I got that from the calculator. Y1, Y2, Y3. Y1, Y2, Y3. Also write the sentence, Again, this is the frustrating part of the test where you may have the right answer on your paper, but you don't know how to type it in. That's a problem. The same numbers, we get some different. Questions. All right, so not only do we have to take the derivative and plug it in, check in the calculator, we also have to know what we're doing. The point of this is to be able to explain. First one would say, at month 5, the total video games sold is 9,366.2 what? Video games or video games per month? I'm playing in the original. So what's the original? Video game. Okay, so be careful. It's not always perfect. The one that's the derivative. 5 into the original will tell me how many total video games. So what does that mean? The whole point of chapter 3 and 4. Right now, 5 months have gone by. 5 months have gone by. I have sold 9,366 games. What is the derivative going to tell me? Next month. I'm expecting to sell how many? 237. Based on how things are going, I've got to be prepared for next month. Does that make sense? So this would say at month 5, video game sales are increasing 237.451 video games per month. Would I mark it wrong if you don't have per month? Of course, because it's wrong. Are we okay? Yep.
What if we have like no investment?
Yeah, if you just round it to video games, that's fine. Again, you're showing your work for all of them. That's the most important part. Are we okay? Now, are video games popular forever? No, eventually they get old. Use your calculator. When would you stop selling this game? Use your calculator. When would you stop selling the game? How many months? How many months? What do you think?
37.
37? Anybody else? 37? Keep in mind, 37 would be like 2.5 years. We'd wait 2.5 years? No, wait a minute. 12 months a year. 33? 3 years and a month? About a month. 3 years and a month? Would you wait 3 years to stop selling the game? Now again, think about this realistically. If I type in 37, 37 makes sense because I'm not going to sell any more games. But you're going to really give it shelf space? So what do you think? Let's see what happens after 1 year. After 1 year, you've made 9,959, you've sold, 9,959 games. You with me? So if I waited 3 years, you would sell how many more games? 41 games in 2 more years. Is that worth it?
No.
Probably not. So you'd probably stop at maybe, like, I probably wouldn't go any more than 2 years. For that 2 years, well, not even 2 years, you're only selling 0.3, or maybe even 18 months. Yeah, what are you going to sell next month? A game and a half. So probably you're going to stop selling in just over a year. Does that make sense? And is that pretty much true? What happens? How many people are running around playing Madden 2005? You'll be surprised. I probably couldn't find Madden 2005, right? Because what happens every single year? Madden 2017. Oh my gosh, you're playing 2017. I'm totally on 2018, right? FIFA 2017, 2018, 2016. So what they do is they make money by making it every single year. And what happens when a game gets old? They make a new one. What happens when all that gets old? A new console. And they just get you and they get you and they get you, right? I have Xbox. What do I have? Xbox One. I had Xbox regular, I think. I had Nintendo. I had Intellivision. Do you remember Intellivision? You don't even know what that is. Intellivision was the competition for Atari. It didn't do very well. It was like the ghetto version of Atari. That's what I had. Listen to exactly. Look it up. Yeah, Intel. It had a little controller with a button. It's what wasn't good. And then so now I'm on Xbox One. So I had Xbox 360, and then now I have Xbox One. The thing is like so sophisticated. I had it all set up when I first bought it, like last year or something. And I would walk in my room and say hello, and it would turn on, and the TV and this and that. And then like I would talk on the phone, and the thing would change channels. I'm like, no, I'm disconnecting it all. Right? That's too much. Okay. Does this all make sense? And if you can type in that, you can type in anything. Are we okay? So the rest of the time, I want you to work on the review. And I do have a couple little things to point out. Number one, I was a little ambitious with number one, so I apologize. You have too many things going on for number one. What I really intend for you to do is input X year, output Y, manatees killed. That's not technically what the problem says. It talks about how many power boats registered and how many manatees killed, but I want to use a real life example that match what we've been doing, so I kind of changed it up a little bit. So I do apologize if you got confused by the power boat thing, but let's just say input is year, output is manatees killed. This still works number-wise. It's just a little weird because I still talked about the power boats in there, so I apologize for that. But again, this is way back in chapter 3, so you may have forgotten about how to do that. This is average rate of change. Here, we really focused on as we get closer, but the big focus was 0.001. Please note, number 3 says use quick approximation. That is a specific method that I want you to use to find that answer for year 7. Question 4 also wants you to find out year 7, but it's using the shortcut method. That means take the derivative by moving the exponent in front, blah, blah, blah. But what do you notice about 3 and 4? It should be the same answer. It's the same answer, but 2 different methods. So on the test, if you do the same method for both, one's going to be wrong. So I am trying to find out if you know how to do the quick approximation. I am trying to find out if you can take a derivative by hand. Be careful when you take derivatives. Show your work, all that wonderful stuff. Number 5. Number 6 is a word problem. And again, keep in mind, your test will have word problems. You'll have to do a creator problem, all that wonderful stuff. But question 1 should be a freebie. Why is question 1 a freebie? You're just plugging into the original. That's all you're doing. That should be a freebie. 1, you're plugging in the original. Question 2, you're finding the derivative. Then you're plugging into the derivative and explaining. Okay? And again, this would be a nice creative problem for you to work on. Just change the numbers. There's another one that talks about cost. Please be careful. I get a lot of mistakes on the test when I shouldn't. Average cost. Average cost is not a derivative. Average cost is not a derivative. What's average cost again? It's the C with a bar, but it's cost divided by X. There's no derivatives in that. Know the function, know how to do it, the calculus, all that wonderful stuff. Yes, you're going to have to do product rule. Yes, you're going to have to do quotient rule. Yes, you'll have chain rule. Remember, you do get half a page in notes front and back. You literally take a piece of paper, cut it in half, front and back, whatever you want to put. Chain rule, logs, logarithmic. There are two number 15s, I don't know why. Please be careful with number 15. This one is a little more difficult. I want you to try that one on your own. 15, the second 15. 16, look at people getting a little confused with. 17 is a word problem. Again, plug in the original, derivative, all that wonderful stuff. 18, most likely 18 will not be on the test, so I wouldn't stress about 18. 18 is kind of like the one we did today. 18 is just like, if you studied everything and you want a harder one, 18 would be your harder one. It probably won't be on the test. I wouldn't worry too much about that. And then 19. If you got a little stuck on 19, 19 is basically a future problem, what your project's going to be like. Every example that I give you, here's the equation, do something. Here's the equation, do something. Here's the equation, do something. Guess what? Equations don't fall from the sky. Where do the equations come from? Data. They come from data. So for this example, number 19, I gave you data, not the equation. You put in your calculator, list 1, list 2. You do exponential regression. That will give you the equation. Now that you have the equation, then you can use it to answer questions. So 19 seemed a little weird because the equation wasn't handed to you. You have to take the data and find your own equation. Are we okay?
Something like that could be on the test.
Good, anything can be on the test. The only thing I'll tell you for sure is going to be on the test is name. Guaranteed. Okay? Now, the last thing I'll tell you is, you probably already forgot, but what was one of the hardest things to you that we did in chapter 3 and chapter 4? You already forgot. Do you remember doing it all by hand? The really, really long problems. We had to plug in x plus h, then it all crossed out, and then you plugged in a 0 and you got the derivative by hand. That is on the test. No, that's the long one. It's on the test as a bonus. It's on the test as a bonus. So yes, you should study, but it's not the most important thing, okay? It's good that we did it. It's good that you understand it, but doing a long, you know what I'm talking about, the long one by hand? Is everybody with me? Right? It's on the test as a bonus. It's on the test as a bonus.
And then you said it was a page?
You take a piece of paper, cut it in half, front and back, whatever notes you want to put. Now, I know it's the same thing as with page one side, but I want it to stand out because you get your creator problem and you get that notes. I don't want a whole bunch of papers all over the place. I want to be able to clearly see that half page is your notes, like what he has in his hand if you need to see an example. It's a piece of paper, cut it in half, front and back, whatever you want to put on it. If it was me, I'd put product rule, quotient rule, chain rule, all 4 special cases. Then you may want to put quick approximation.
We don't write anything on
Anything, you can put the whole review on there, super, super small.
Yes.
But it doesn't help. The reason why it doesn't help is you'll be the one staring at your test, staring at the notes, staring at the test, staring at the notes. You'll be squinting because it's so small. If you know it, you know it. If you don't, you don't. It really doesn't matter. My ideal goal, what I love is when people make the notes and they spend so much time on it, they study through it, they don't even look at it during the test because they spend so much time. It's like a study method, really, making a note. Are we okay? I'm going to turn this off real quick.